3-part videos Zero Pollution 2050 were released on YouTube channel in February 2021. Part 2 provides the need and basis for sunset to sunrise, that is S2s Energy Storage. The global S2s energy requirements by 2050 is 40,000 terawatt-hours per year, which is 20 to 25% of 180,000 terawatt-hours per year needed by 2050. Globally, hydro plants generate 5,000 terawatt-hours per year and was therefore not considered as a viable solution. Other options like compressed air, water, batteries, etc. were proposed.
I have now reassessed this. This video proposes to revise the above S2s storage energy needs by using UHES or upgraded hydro energy storage. The graph providing the need and basis for S2s energy storage is presented here again. During the day, solar energy provides the energy for immediate use and sunset to sunrise or S2s energy needs. During the night, S2s energy storage only by itself provides solar electricity. Globally today, the hydro plants provide 5,000 terawatt hours per year using the 1 terawatt hydro plants. Societal objections to new hydro sites prevent any major growth in the future. A review of hydro plants provides the following observations. Hydro plants are mostly based on an open loop design, more than 80% of them. In this design, water is stored for the whole year's needs in large reservoirs. The water is then released to hydro turbines below to generate electricity when needed. The water is then discharged to a canal or other water body at the lower level. Water is, however, used just once from the reservoirs to the turbines and then discharged, and is hence known as open loop hydro. In pumped hydro storage, also known as PHS, consists of upper and lower reservoirs. Water is stored and released to the turbine below to generate electricity on demand, as in the open loop design. However, the water is now discharged to a lower reservoir for storage and reuse later. When electricity is available from the grid, the turbines pump the water back to the upper reservoir. This cycle is repeated and is known as a closed-loop design and reuses the stored water many times.
It is proposed to upgrade and convert the open-loop hydro facilities to closed-loop S2s energy storage or UHES to meet all of the S2s energy storage needs by 2050.
The 1000 megawatt THERI project in India has been assessed for the above conversion as follows. The main reservoir is 4 km cube. The design head and flow at THERI is 188 meters and 580 cubic meters per second. The proposed UHES rating would be 10,000 megawatts or 10 gigawatts, generating 120 gigawatt hours per day, operating 12 hours a day, or 40 terawatt hours per year. Proposed UHES reservoir needed at Tehri would require 0.25 kilometer cube, or just 6.25% of the main reservoir. The additional height of the lower reservoir would be only 8.6 meters. Additional equipment like the pump motor, turbine generator, penstocks, civil facilities, etc. would be needed. Upgrade of the electrical grid connection would be required. However, as the grid has to be upgraded for the zero pollution solution, there will not be any problem here.
In conclusion, a global UHES system requires the existing global 1 terawatt open loop facilities be converted to a 10 terawatt closed loop system. Upgrading the 1 terawatt hydro turbines to 10 terawatt by adding new pump motor turbine generator sets. Installation of larger penstocks and other support facilities. Only 120 terawatt hours of water storage or reservoirs in the upgraded discharge facilities. They operate in a 12 by 12 hours daily cycle to pump or generate. The lower reservoirs will be just 2.5% of 5,000 terawatt hours per year, main reservoirs capacity, avoiding societal objections. A global 10 terawatt UHES system can provide the 120 terawatt hours per day, that is 40,000 terawatt hours per year, to provide zero pollution, 24/7 uninterrupted solar electricity around the globe by 2050 or earlier.